As a reliability engineer, let me tell you, I've seen a hidden killer derail so many promising products right at the finish line. It's something most teams just don't see coming until it's way too late. So today, I'm going to walk you through what this hidden threat is, and more importantly, how you can make sure it doesn't happen to you.
And look, the stakes here, they really couldn't be higher. A failed certification isn't just a little bump in the road, it's a potential catastrophe. We're talking massive financial hits from recalls, total redesigns, and something that's even harder to get back, your brand's reputation. It's the absolute nightmare scenario every single product team is trying to avoid.
So, what's the deal? What's actually causing these epic failures? It's usually not a bug in the software or a bad design choice. Nope, it's a critical blind spot, something that lives in the invisible world of electronics. So let's shine a light on this hidden product killer.
The problem? It all comes down to the invisible forces swirling all around us. In our world today, everything's connected, right? Well, that means every single electronic device is living in this crowded, incredibly noisy electromagnetic environment. And its ability to survive and thrive in that chaos is decided by two things: electromagnetic interference and electromagnetic compatibility.
Okay, first up is EMI, or electromagnetic interference. The easiest way to think about it is just electrical noise. Every phone, laptop, Wi-Fi router, you name it, it's all generating this stuff. And when you cram all those devices into one space, you get this invisible storm of energy that can seriously mess with how a device is supposed to work.
And that brings us to the goal, EMC, or electromagnetic compatibility. This is the whole enchilada. This is the ultimate test. Can your product do its job perfectly in the real world? And, here's the kicker, can it do that without shouting over all the other devices and causing problems for them? It's really all about being a good citizen in a very crowded electronic world.
So, how do we actually get there? How do we achieve this, electronic harmony? Well, this is where so many engineering teams get it wrong. They think it's just a one-sided problem. But EMC is a two-part test, and you absolutely positively have to pass both. Let's break down what that really means.
This, right here, is the absolute truth that gets missed all the time. You can build a device that's perfectly quiet, doesn't bother a soul. But if that same device can't handle the noise coming at it from the outside world, it still fails. Period. There's no partial credit. Both sides are mandatory. No exceptions, ever.
The best way I found to explain this is to think of a two-sided coin. It's simple, right? One side is emissions, the other side is immunity. You can't have a coin with only one side, and you sure can't have a certified product that only passes one of these tests. You need both to win.
And this chart just lays it out perfectly. On the left, you've got emissions. I call this being a good neighbor. We're measuring the junk your device is putting out into the world, making sure it doesn't mess with radios or Wi-Fi. Then on the right, you have immunity. This is all about ignoring bad neighbors. Can your device hold up when it's getting bombarded with energy from everything else around it? So when we're testing those emissions, we're basically looking for two escape routes for that noise. Radiated emissions, that's the stuff that travels through the air, kind of like tiny radio waves going where they shouldn't. And conducted emissions, that's the noise that hitches a ride on power cords and cables, polluting the whole system. Now, immunity testing. This is where we get tough. This is all about ruggedness, about real-world survival. We literally blast the device with energy through the air. That's radiated susceptibility. We inject noise right into its cables. That's conducted susceptibility. And then we throw real-world hazards at it. Can it survive a static shock? That's your ESD test. What about a power surge from a nearby lightning strike? We test for that too. All right, now that we know the two sides of the coin, let's connect this all the way back to those serious consequences we talked about at the start. Because failing either one of these, emissions or immunity, it leads to the exact same place, a failed product.
And I really need to hammer this home. This is not a sliding scale. You don't get bonus points for passing one but not the other. It's a pass-fail. It's a binary outcome. Failure on one side means total failure of the whole certification process, and that's when the real business headaches start.
And these headaches are severe. I mean, you're looking at having to recall every single unit you've already shipped. You're facing crazy expensive last-minute redesigns that can push your launch back by months. Your brand's reputation, which took years to build, gets a huge black eye. And worst of all, sometimes these failures can create real safety hazards for the people using your product.
Okay, I know, it sounds pretty dire, but here's the good news. There is absolutely a way to prevent all this heartache.
It just takes a shift in mindset, away from just hoping you pass a test at the end and toward building a tough, resilient product from day one. This is the reliability engineer's playbook.
The solution is all about being proactive, not reactive. You have to design for compliance. That means thinking about things like shielding and grounding right from the very first sketch. And, this is critical, you have to test early and test often. Finding a problem on a prototype, that's an easy fix. Finding it after you've already manufactured 100,000 units, that's a full-blown disaster.
Now, don't worry about memorizing all the standard numbers on this slide. Just take a look. The point here is just to get a feel for the gauntlet a product has to run. We test for static shocks, for power bursts, for surges, for voltage dips. Each one is simulating a real-world event, and it just shows you why you need a solid plan from the start.
So this is it. This is the path to a successful launch. It's a clear, 4-step strategy. Number 1, design for compliance from the very beginning. 2, test early. Do pre-compliance testing to find the problems when they're cheap and easy to fix. 3, go into those final, official certification tests feeling confident because you've already done your homework. And 4, launch a product that you know is reliable, safe, and truly resilient.
So that leaves us with the one question you should be asking about your product. It's not enough for it to just be a quiet, good neighbor that doesn't cause any trouble. It also has to be tough enough to be truly resilient in a very loud, very chaotic crowd. Because passing both sides of that test, well, that's the only way to win.